Good morning to all. Myself, Dr. Jincemon Cyriac. Now I'm working as assistant professor in Marian College, Kutikanam Autonomous. Here I am going to present my PhD thesis for the award of Professor Sabu Thomas PhD Thesis Award 2023. My thesis is entitled Defect Analysis in Rare Earth Doped BiFeO3 Multiferroic System using positron annihilation spectroscopy. I completed this work under the guidance of Dr. Saji Agustin and Senior Professor Dr. PMG Nambishan sir, Senior H, Saha Institute of Nuclear Physics, Kolkata. Nowadays, multiferroic material has several applications in the field of memory storage devices, sensors, actuators, etc. Because simultaneously we can change the electric and magnetic properties of this material at room temperature. And also we know that defect play an important role in the property of this type of semiconducting material. In this case, in this report or thesis, I prepared BiFeO3 phase pure multiferroic system and the rare earths such as europium, dysprosium, praseodymium, which are doped into the Bi3 plus site, and chromium 3 plus ion is doped into the Fe2 plus site. Actually, these doping of this rare earth and Cr3 plus enhanced the dielectric, optical, structural, magnetoelectric coupling property of this material. So all these work here I concluded into or presented into as my working chapters. Europium substituted bismutheric nanocrystals by positron annihilation and other methods. Dysprosium substituted chapter. Chromium substituted chapter in Fe site. And praseodymium substituted chapter. And I tried to fabricate the resistive random access memory cell for the switching properties. So we can change the properties by applying electric field and magnetic field also. So we can use this material as a switching material by applying external electric field and also by applying external magnetic field. Here, praseodymium doped nanomaterial at Bi3 plus site is used for this ReRAM fabrication, and the switching property is obtained by studying the IV characterizations. The thin films are prepared by pulsar laser deposition in IAST Trivandrum under the guidance of Dr. Jinesh KB sir. Now, as I mentioned earlier, here BiFeO3 is a multiferroic material and it has two FeO6 octahedra. And around this 111 axis, which are rotating in, one is rotating in clockwise and another rotating in anti-clockwise direction. So this rotation of this octahedra gives some Dialosinsky-Moria effect or the symmetry loss within this material. Due to this symmetry loss, it gives the magnetoelectric coupling properties. That means one phase is ferroelectric, another is G-type antiferromagnetic. The Bi3 plus ions has 6s2 lone pair electrons, which gives the ferroelectricity of property of this material. And the partially filled 3d5 orbital of Fe3 plus ion gives the G-type antiferromagnetic property. The overview or the objective of the work, the synthesis of pure sample, europium, dysprosium, praseodymium doped at Bi site, chromium doped at Fe site, studied the structural, morphological, optical properties. The defect analysis done by positron annihilation spectroscopy. Then the dielectric and magnetocoupling property is studied. Finally, ReRAM memory cell is fabricated by using praseodymium doped BiFeO3 thin film, which is deposited by pulsar laser deposition or PLD. All the samples are prepared by sol gel method, and the first unit or the first chapter, the doping of europium ion. This work is published in two paper, Journal of Physics D Applied Physics, and also in Materials Today proceeding. In this, the doping enhanced the structural properties, and at a particular concentration 0.2, when x is equal to 0.2, there is a structural transformation is okay. And this structural transformation enhanced the UV absorption spectroscopy property. The band gap is decreased. The band gap is decreased due to the defect-induced energy level formation between oxygen 2p state and Fe3d state. Then positron annihilation study is done. And from the positron annihilation study, it is confirmed that there is tau2, the lifetime of positron. That means there are two types of positron is present here, birth positron and annihilation positron. When a Na22 source is radioactively undergo disintegration, it will produce Ne22. At that time, it will produce one gamma ray. And this gamma ray is penetrated to our powdered sample. And if there is any vacancy, this positron can spend some time there. So we can classify the time into tau1, tau2, and tau3. Tau1 is a lifetime in the bulk region. Tau2 is the lifetime in the defect region. Tau3 is the lifetime in the formation of positronium ion. Here we can discuss the formation of tau2 or the variation of tau2. This tau2 is increased and I2 means the number of vacancies. The number of vacancies decreased, the tau2 is increased. That means at x is equal to 0.2 or greater than 0.2, there is a change in tau mean or mean lifestyle is obtained. It indicate the structural transformation. And also by studying the coincidence Doppler broadening spectroscopy or CDBS, we can find out the momentum of the electron which undergo the annihilation by using this formula, and the electron, the 2p electron of the oxygen ion undergo this CDBS or the annihilation from the CDBS spectrum, which can be analyzed by LAM software. That means oxygen 2p vacancies are presented or formed within the sample. So this vacancy of oxygen 2 minus ion and some vacancy produced, that means the positron entered to the Bi3 plus type of vacancies. There are two types of spatial vacancy or space charges formed, which togetherly considered as a space charge or dipole. So here, by studying the dielectric property of the material, the dielectric property is maximum is obtained at the concentration x is equal to 0.2. It is also due to the structural transformation. Again, I studied the magnetoelectric coupling property, that is due to the Dialosensky-Moria effect, the existence and bending of Fe bond, and the maximum value is obtained for the sample x is equal to 0.2. So when the europium dope at a particular concentration x is equal to 0.2, you obtain the maximum optical dielectrical hemicoupling property due to the vacancy type defect, which are concluded by this chapter. Chapter 2, dysprosium is substituted in this Bi3 plus site, which is published. This work is published in Physica B, Physics of Condensed Matter. Here also some impurity speakers are generated. So I did the ritual analysis of all the samples. And some impurity peaks is formed in the pure sample, but the impurity of the sample is decreased by doping of dysprosium ion. Here also there is a structural transformation from rhombohedra to orthorhombic PNMA phase is formed at X is equal to greater than or equal to X 0.15 concentration. The nanoparticle formation is confined using TEM. The elemental concentration or composition studied using EDAX. Here is the gradual decrease of optical properties obtained due to the additional vacancy type defect level is formed between oxygen 2p to Fe3D state. The positron annihilation study again confirmed the formation of the vacancy type defect, and the LAMPS analysis software gives the result that is the disintegration is due to the oxygen 2- ion. Here also the dipoles are formed within the sample, which gives very attractive dielectric and Me coupling properties. And there is a large increase in the dielectric constant. So this material are very useful for the fabrication of energy storing or devices such as capacitors, etc. The magnetoelectric coupling property is so studied, and the maximum value is obtained at the concentration X is equal to 0.2, where the maximum Fe or Fe bond bending is okay. In the next chapter, the Fe site is replaced by Cr3 plus substitution, and the chapter is studied and it is published in Physica in low dimensional systems and nanostructures. Here, but there is no structural transformation is occurred. So when we adopt a rare earth material into the Bi3 plus, the structural transformation is obtained. But when we replace the Cr3 plus in the Fe3 plus side, there is no structural transformation okay. And also the band gap energy is decreased. The lifetime also it is due to the formation of vacancy type defect. Here the momentum is corresponding to the value that is due to the 2p electrons. That momentum is equivalent to the 2p electrons of the oxygen ion. The dielectric study or dielectric property here decreases. That is due to the structural morphology here increased. When we adopt chromium ion into the Fe site, the more chromium atom aligned in a perfect manner and the structural morphology or surface morphology increased and the dielectric property is decreased. Magnetoelectric coupling property also increased by doping in A site or B site or Bi site or Fe site. Here also some spin current is developed within this material and the magnetic electric coupling property enhanced. Finally, I studied the application of this work, such as I would like to present the formation of thin film by pulsar laser deposition. In which the thin film that is chosen in the praseodymium doped Bi 1-X PRX FeO3 for the different concentration X is equal to 0.1. The pulsar deposition done by these conditions and the thin film is obtained and the gold electrode is deposited into it and studied the Vi characteristics and the on-off state is obtained from the Vi study. But for the PR doped thin film, there is a very beautiful result is obtained and the V on state is obtained around 3 volt and the switch is become on and it become off approximately to the voltage 2 volt. So there is a threshold switching is obtained and it is due to the conductive filament formation of these vacancies which are aligned to a particular direction, and when we applied the voltage, the electrons are flowing the topmost electrode to bottom up electrode through this conductive filament of oxygen vacancies. So these rare earth material are very useful for the fabrication of these memory devices or resistive RAM memory devices. So we can incorporate a different material as in future work. And also now we can study more similar works in the field of nano composites, that the different type of ferroelectric and magnetic materials is immersed into one system and we can use it as nano composite system. Then we can study the same properties and we can also study the device fabrication such as resistive random access memory and also in terms of spintronics and also it can be applicable in the field of thin film, or we can use it as gas sensors, actuators, etc. So the work is very relevant to the society, and these are the major my acknowledgement to the research and my guide and faculties that give the help and throughout my life. And thanks to all, thanks to you.